A programmable logic controller, or PLC, is a digital computer that's designed for machine control. The PLC uses inputs and a program logic that interprets from the state of the inputs the state of the outputs. Some of the inputs that are used on the Biotronic trainer are inductive sensors, capacitive sensors, photo eyes, and push buttons. Some of the outputs are motors for chain and belt drives, and solenoids to sort the pieces. Now, let's see how the program reads and responds to the inputs to operate the trainer. When the start push button is pressed, it sends a true signal to input 6. When input 6 goes from false to true, it tells the PLC to send signal to outputs 0 and 4. When outputs 0 and 4 are true, the examine if closed instructions that are in parallel become true, creating a seal-in. This allows the belt and chain drive to continue to run when the start push button is released, and they will continue to run until the stop push button is pressed.
Perfect. No.
When the piece reaches the top of the hill on the chain drive, it passes an inductive sensor, a photo eye, and a solenoid. If the inductive sensor detects that the piece is metal, it starts a time-off delay. The done bit on the time-off delay is associated with the examine if open instruction, which when a metal piece trips the sensor, the time-off delay prevents the reject solenoid from firing, allowing the metal peg to continue to the slide. If the piece is a plastic ring and the inductive sensor doesn't go true when the piece passes through the photo eye and input 1 goes true, then output 1 changes to true and energizes the reject solenoid, sending the plastic ring to the hopper. Every time the reject solenoid energizes, the counter accumulates another count. And when the count hits 5, the examine if open instruction associated with the counter prevents the reject solenoid from energizing, and the plastic ring is allowed past and is collected at the end of the chain drive. As the metal pieces are allowed past the reject solenoid, they go down a slide, where they meet the conveyor belt. The conveyor belt sends the metal piece past the hopper, where the metal peg is crowned with a plastic ring. As the plastic ring is removed from the hopper, a photo eye corresponding with input 2 goes from true to false. The examine if open associated with input 2 goes true, giving the signal to output 2 to energize the rotary solenoid. This puts the next plastic ring in position for the next metal peg and decrements the accumulated count by 1. The belt now carries the piece through 3 more sensors, an inductive, capacitive, and eventually another photo eye. The inductive sensor is associated with input 8 and goes true when the metal peg passes through. The capacitive sensor works like a normally closed switch, and input 3 will go false when the capacitive sensor senses a crowned piece. Completed pieces are allowed past the final photo eye and solenoid to the finished area. If the metal peg passes these sensors without a plastic ring, the time-off delay starts. While the time-off delay is counting down, the examine if closed instruction associated with the done bit becomes true, and is in series with the input associated with the final sensor that when both examine if closed instructions are true, then output 3 energizes the reject solenoid, and the metal peg is prevented from collecting in the finished area.